teacher. My name is JINDAPORN258. This is the topic in stat quality subject. Let me present. The first one is the sample fraction non-conforming. The second is the NP control chart, and the last one is control chart.
Let's start with the sample fraction non-conforming. For this formula is p hat equal d divided by n. N is sample size and d is the number of non-conforming. And 3 sigma in this square is the 3 sigma of fraction non-conforming control chart. Upper control limit is equal to p plus 3 square root p multiplied by 1 minus p and divided by n. Next, center line is equal to p, and the last lower control limit is equal to p minus 3 times square root p multiplied by 1 minus p and divided by n. All of this is the main formulas of p chart. There are two ways to calculate unknown value of p. For the first way, p hat equal to d divided by n. D is the number of non-conforming, n is sample size, and you can calculate it for each data of d and n. For the second way, is calculated from the p bar is equal to summarize of d value divided by m multiplied by n, or equal to summaries of p hat divided by m. M is the number of sample groups. Then you can construct the graph of non-conforming by p hat value with the sample number. For the second chart is the NP control chart. The NP control chart is based on the numbers of non-conforming rather than the fraction non-conforming. The formula for calculate the NP control chart. Upper control limit is equal to n times p plus 3 square root n times p times 1 minus p. For center line is equal to np. For the lower control limit is equal to n times p minus 3 times square root n times p times 1 minus p. But there are some problems about the difference of sample size and how to fix the problem. What if the size of sample is different? There are 3 ways to fix the problems. 1. Variable with control limits. 2. Control limits based on average sample size. And 3. The standardized control chart. For variable with control limits, p bar is equal to summarize of di value and divided by summarize of ni value. Ni is vary according to size of each sample. But to suggest something about this way, your graph is unstable because the difference of sample size, like both of this picture. But the second way is better because you use just only one n is average n. By calculated, n bar is equal to summarize of ni value divided by m. And the last one to fix the problem, you use the standardized control chart by calculate set value is equal to p hat minus p. All of this divided by square root p times 1 minus p divided by ni value. Then construct this graph by use set value from each calculate of ni value. And the last chart of my presentation is control chart. It's based on the total number of nonconformity and average number of nonconformity per unit. And the formula to calculate 3 sigma of control chart for nonconformity are upper control limit is equal to c bar plus 3 times square root c bar, and center line is equal to c bar. And the last lower control limit is equal to C bar minus 3 times square root C bar. And after the first calculate, you will see that what the value of number of nonconformity is out of control. You have to cut off the number of nonconformity that out of control and next step to recalculate and construct the new chart. For example, at the first, if there are 26 samples and contains 516 total nonconformities, C bar is equal to 516 divided by 26 is equal to 19.85. And 3 sigma of C chart upper control limit is equal to 33.22. Center line is equal to 19.85. Lower control limit is equal to 6.48. So the table of data is shown that there are two values, R5 and 39. The number of nonconformity are out of control. Because the 5 is lower than lower control limit and 39 is upper than upper control limit. So we have to cut off two values. So recalculate the C bar value. So I will compare old one and the new one of C bar. Like I showed you before, C bar old one is equal to 516 divided by 26 is equal to 19.85. And the new one, after we cut off the value of 5 and 39, it will left 422 and cut off the number of two samples that we cut off. 26 minus 2 is left 24. So the new one of C bar is equal to 472 divided by 24. It will equal to 19.67. It will the correct value of C bar. Then you can construct the right C bar chart by use the new one value of C bar.
Finally, thank you for your attention.